So in this case, we are going to consider as a continuation working with the general solutions as part of our trigonometric equations as we consider the trig equations. How do we end up with general solutions? So general solutions, actually, here we are referring to all the solutions, a set of solution values for any given interval or any given period. So it general solution here represents a set of solution values for any given interval. So for the given interval or a given period, we can have a set of solution values. So each and every trigonometric equation, whether it is given in terms of the sine, it is the cos, or it is a tan, we can determine its general solutions. So the first thing is the layout of an equation. The first one, given the sine of x or the sine of theta as an angle, whatever that you're given, which is equal to a in that case. So that is, we are given sine of x, the sine of theta, whatever that we're given, equal to -1. It can be +1. It can be 0,5. It can be 0,3. So this is the part representing our a. So definitely a must be a real number there. But this a that we are referring to must be, so where a is greater than or equal to -1, but less than or equal to 1. We cannot have, or we cannot solve something sine of a certain angle, whatever that we have, equal to anything that is out of this interval that we are given, out of this. -2, -3, +4, +3. We cannot have such because of the interval. The number a must be in within -1 and 1. And that a being what? A real number. So in order for us now to determine the general solution for such a condition, first we determine the reference angle. The reference angle. First, we must determine the reference angle, and you must consider, because a can be positive, a can be what? Can be negative. So the reference angle is not affected by that one. Is not affected by that. So we must determine or find the reference angle. So I'm just going to write in short, reference angle. You can write ref angle like that for the what? For the reference angle, or just in short, reference angle like that. So this is for what? The reference, for the reference angle. Arcsine of the magnitude of A. You take it as a positive. So the reference angle will be equal to arcsine, the modulus of what? Or the magnitude of A. You consider as a positive. Don't include the negative. It is -0,5. The magnitude, we need it as a positive. Just take the positive. Don't worry about the negative that you're given. The negative is for the quadrant to say which quadrant is it that a sign is a negative from that cast concept. That is where you consider, all right, there's a negative, so sign is negative in these two quadrants. Or it's positive, so it's positive in the first and the second quadrant. That is where the sign plays a role. So on determining the reference angle, you ignore that sign. You just use what? The number as it is, the magnitude as a positive. So now, if we have a condition that A is positive now, that is where you are supposed to consider the quadrants. If A is positive, meaning to say the sign of x is equal to positive, for an example, the sign of x is equal to 0.5. When it is a positive like that, we consider the quadrants where sign is what? Positive. We are dealing with sign. So from the cast concept, sign is positive where? In all the first quadrant and the second quadrant. So in the first quadrant, we are going to have this represented by the reference angle. Here, this is our reference angle. So at the end, the angle that lies in the second quadrant will be given as 180 degrees minus the reference angle. We're going to get rid of that reference angle, just like what we had before, 180 degrees minus theta, the acute angle. Reference angle, that's the acute angle that you're going, it's an acute angle. This one is always an acute angle that you're going to have. So that's 180 minus the acute angle, reference angle. So these were supposed to be the solutions taken from 0 to 360, from 0 to 360 degrees. But now, as a general solution, in our case, as general solution, in the first quadrant, our x is going to be equal to the reference angle as it is plus, we must consider the multiples of 360 degrees because this was taken in an interval of what? 360, from 0 to 360. So we consider now the multiples of 360 degrees. Remember, multiples, if we say multiples of 2, 2 times 1, 2 times 2, 2 times 3, multiplying, those are multiples of what? Multiples of 2. So we consider k times 360 degrees, where k is what? An integer. Where k is an integer. So this is for the solution which lies or which represents all general solution, all solutions that will lie back to the first quadrant. Reference angle plus what? K 360 degrees. So k can be substituted now to obtain exact values, integers. 0, -1, -2, -3, 1, 2, 3. You substitute in place of k to obtain exact values. So this is what you're going to have in the first quadrant. Or we are going to have another solution obtained from the second quadrant. So the first one is the primary value, which is this one, the primary value. The one in the second quadrant, the second solution is the secondary value. So in that case, our x will be equal to the angle represented in the second quadrant where sign is what? Positive. The angle there is what? 180 degrees minus the reference angle. So this is what we are going to have as our angle. Plus what? The multiples of 360 degrees, k times 360 degrees. So this will be our condition, where k is what? An integer. So these are the two solutions that we are going to have for A, which is positive, our general solution is going to be like this, where it is positive in the first quadrant and the second quadrant. That is where sign is positive. So meaning to say, if our A was a negative value, the solutions, guys, were going to change. If this was a negative value, we are going to have something else. Meaning to say, for negative values, all right, so let us consider for the solutions when these are negative, for negative what? For negative values, all right, so in this case, we are going to consider if A is what? Is negative. If it was a negative value, for an example, we can consider the sign of x being negative 0.5, a negative. This time you consider where the sign is negative. Where is it that a sign of a certain angle gives us a negative value? In which quadrants? In which quadrants? So in our case, from the cast concept, where is it that sign is negative? In the third, the fourth quadrant. There we do not have sign. Remember, the first it's for all. Second is for sign. So this is where we're going to have our sign as a negative. Where each quadrant, remember, it has a reference angle in it. In each quadrant, there is a reference angle. So therefore, the solutions were going to be what? The angle that lies in the third quadrant. Remember, 180 plus theta, 180 plus the acute angle. So here it's 180 degrees plus what? The reference angle. 360 degrees minus our theta. Our theta is what? The reference angle in the fourth quadrant. So thus we can have our general solutions as before. So our general solutions were going to be taken as what? In the third quadrant, where sign is negative, x will be equal to the angle in the third quadrant, 180 degrees plus the reference angle. Then the multiples of what? 360 degrees. Where k is an integer, just like before. This is what you're going to have. So we do the same thing for the angle that was going to lie in the fourth quadrant. So this is the one for the third quadrant. For the fourth quadrant, our x was going to be taken as 360 minus the reference angle. So that's 360 minus the reference angle plus k times 360. Just like that. We are going to have that as our general solution. For what? Negative angles. For negative values of a sign. If sign x is equal to negative, remember we did not consider the negative when determining the reference angle. We took arc sine of the positive value. Arc sine, remember from your grade 11, guys, we talked about this. That is shift sign. Shift, we press the sign, arc sine of what? 0.5. This is your reference angle, the acute angle that you obtain. Then you use it according to the quadrant. Now you must figure out to say, which quadrant exactly am I going to have my solutions according to what I'm given, because of the sign that is positive, or that is what? That is a negative. So if it is a negative, your solutions will be in the third, and in the what? In the fourth quadrant. If sign is positive, your solutions will be in the first and the second quadrant. So this is the same thing, guys. The 360 degrees that we are using is for the period that we have, the period of a sign. Remember the sign graph? So you consider its multiples. It is the same thing even for a cos. All right, let's consider the second one for a cos. So given or if the cos of x is equal to a on the same condition, just like the previous case where our a is greater than or equal to -1, but less than or equal to 1. And this a being a real number, what are we going to do in this case? Just like the previous case, use the same concept to find the reference angle. We must determine or find what? The reference angle, which in our case we are dealing with cos. So the reference angle will be taken as what? As arc cos. So that's our reference angle is going to be arc cos of what? Of A. The magnitude, we need the magnitude of A there, the positive. As a positive, you ignore the sign that is given. If it is a negative, ignore that. The sign will be used later on from our quadrants now. That is where the sign is to be used. After you have determined, after you've determined, after you have determined the reference angle, then you can use the quadrants now, just like what we had in the previous case. So number one, we are going to consider A being positive, like what we had. Where is it that we are going to have our cos? So if A is what? Positive. All right. For an example, we are given the cos of x being equal to 0,3, whatever that you're given. It's a positive value. You have your reference angle. So you consider the quadrants. In which quadrant is it that cos is what? Positive from our cast concept. Cos, where is it positive? In the first, all, and the fourth quadrant for cos. Remember, we talked about these quadrants, guys. So each quadrant has a reference angle. Here, there's a reference angle. Here, there's a reference angle here. Even here, each quadrant. But we're not going to consider these two because we are considering only for a cos where it is positive. So the first quadrant is just the reference angle as it is. In the fourth quadrant, remember, angles can be taken now. It is up to you. Are we going to consider it as a negative or as a positive angle? If we take it as a positive angle like this, the angle will be given as 360 degrees minus the reference angle, minus theta. But if we take it in the clockwise direction, it's a negative angle, this one. So it's minus reference angle. It's one and the same. So that's why you see other books, they'll be just writing plus or minus because they consider the positive angle in the first quadrant. In the fourth quadrant, as a what? As a negative angle plus 360, k times 360. They can just take it that way. It is one and the same as considering separately in the first quadrant. For the general solution, our x is going to be equal to what? The reference angle as it is in the first quadrant plus k times 360. Remember, cos and sine, they have the same period, 360 degrees. So this is what we were going to have for all integers. And where else that cos is what? Positive. In the fourth quadrant as a positive angle, taking it in the anti-clockwise direction, that's 360 degrees minus what? Minus the reference angle. So we must subtract the reference angle from 360 degrees. So this is what we are going to have, of which we could have taken it in the clockwise direction as a negative angle. So someone here could just have written as minus a reference angle here as a negative angle. So that's why you end up using the plus or minus concept. All right, plus or minus. Let me just write it here. So this is for the fourth quadrant. So that's where you end up having just x is equal to plus or minus a reference angle plus k times 360. It's one and the same. It's one and the same. This is a positive angle minus. Remember, guys, we talked about how we take positive angles and how we take negative angles. So that one, I just hope we are in the same direction. If this is new, make sure that you go through the playlist from the first video. I think you can be able to get assistance of what I'm referring to from the basics. So this is it for a cos that is positive. Cos x is 0,3, 0,5, whatever that you're given. What about when it is a negative? Just like what we had here, we are going to use the same concept. Same concept. If A is negative. So if our A is negative, for an example, you are given the cos of x being equal to negative 0,5. If cos of A, cos x is equal to A, and the A there is a negative value, you must consider the quadrant where cos is what? Negative. In which quadrant or in which quadrants is it that cos is negative? The second and what? The third. Remember, the concept does not change. In each quadrant, there is a reference angle. In each quadrant, there is a reference angle. How do you write angles in the second quadrant? 180 degrees minus theta. Our theta is what? The reference angle. Remember, that's a positive angle that in this direction. You could have just considered the other way. In the third quadrant, 180 degrees plus what? The reference angle, 180 degrees plus theta. So therefore, our general solutions can be determined. X is equal to what? In the second quadrant, 180 degrees minus the reference angle. That's our angle plus what? K times 360. That is the condition where K is what? Integer. So we have a solution from the second quadrant where cos is negative. Cos is also negative in the third quadrant, and angles in the third quadrant are given as 180 plus theta. Our theta is the reference angle there. So that's it. Just like that. So we are going to have the general solutions for negative values in the second and in the third quadrant. Cos is what? Is a negative. It gives us a negative value there. So it is something to be considered. So 360 degrees from the period that we have of these two graphs, sine and a cos, remember they have a period of what? 360 degrees. So that's, we are going to use that one. So this is it. If it is positive, those are the solutions that you're going to have. So guys, as we can see, it's all about revision. It's all about revision. Angles, whatever, the trig ratio that you're given can be positive, can be negative. You must consider that. Then the last one is for a tan. So the tan of x, if we are given that one, okay, so that's the third and the last trig equation, the format that you must have. Given that, or if we are given the tan of x being equal to a, just like the previous case where our a is greater than or equal to -1. So in our case now, it cannot be -1 because tan remember, tan is limited in terms of its range, the output, the input can be affected in other cases, but what we have as a result cannot be limited to say we can have from 1 to this. Tan is not limited. This is if we have something like tan, let us just tan 60. Tan 60 is greater than, was supposed to be greater than 1. As you can see, 1,7 is greater than 1. Tan 100 degrees, let's see, minus 5, you see, we never had these values for sine and for cos. We never had something like that. So tan is not limited. That A can be, any part can be any number. So let us just take from minus infinity up to the positive infinity. That is the condition of what? Of our A. It's not limited. It's not limited. But just like what we had before, we must consider where each is positive or negative, or you must consider each to say, is it positive or is it negative? But always a reference angle first. We must find our reference angle, which in our case, it is going to be arctan of what? Of the magnitude of A. We consider the magnitude of A. You ignore that thing, that sign that you're given there, then just use it as what? As a positive. As a positive there. With the reference angle, you can now consider the general solutions depending with the A that you're given to say, is it negative or is it a positive? So 1, if A is positive, which quadrant are we considering? For an example, the tan of x is equal to positive 1. In which quadrant is it that a tan is positive from the cast concept? All, the first, and the tan, third quadrant. Knowing that each quadrant has what? A reference angle inside of it, we can determine the angles. The first quadrant is just gonna be that reference angle as it is, but remember the third quadrant, 180 degrees plus what? Plus the reference angle. We must add the reference angle to that. So meaning to say, we can determine our general solutions at the end from these two, where tan is what? Positive. X will be equal to, in the first quadrant, reference angle plus what? K times 180. From the period of the graph of a tan, 180 degrees. You must be very careful there. You add 180 degrees, and that must be an integer. All right. So that's for the first quadrant. Or we can have our x as what? In the third quadrant, 180 degrees plus the reference angle, plus k times what? K times 180 degrees. So this is what we are going to have, and k being an integer. Two solutions are going to be obtained. One in the first, another one in the third, where tan is positive, taken to its period of what? 180 degrees. Using the same concept, we can determine when our A is what? A negative value. And when this A is a negative, if A is what? A negative, For an example, we can have the tan of x being equal to -1. The whole process is the same, determining of the reference angle. But we consider now to say where exactly is this tan a negative. The fourth and what? The second. Here, our reference angle. Here, our reference angle. So the angle there will be what? 180 degrees minus the reference angle. Here, 360 degrees minus our reference angle, which is our theta, or we can take it as minus the reference angle as before. It is up to you that as a negative angle, but I'm just going to use positive angle so that we do not confuse each other. So therefore, our general solutions, we're going to be taken as x is equal to what? In the second quadrant, 180 degrees minus the reference angle plus k times 180 degrees. And the fourth quadrant, where it is a negative, that's 360 degrees minus the reference angle plus k times what? K times 180 degrees, all right, from the period of the graph of a tan. That is what we are going to have for our k being what? An integer. These will be our solutions, the general solutions. For any integer value of k that we substitute, it gives us a solution. So that's where the interval now plays a role, where you'll be given in within this interval from 0 to 360. So your solutions now must be in within that interval for you to have exact solutions. Remember I said the general solution, it carries all, all solutions are here, all of them. For any interval, for anyone, any interval, general solutions carries all solutions for course they are here. Only that you just need an interval that you use now to say, okay, I'm dealing with positive values, so I'm just gonna dual or deal with this quadrant. So that is it. So let us just conclude with this and information, then try by all means to look into some of the examples for general solutions. Because the trig functions are periodic, there will be a number of possible solutions to an equation. You need to write down the general solution of the equation. Once the general solution has been solved, write down the general solution by adding the following k times 360 degrees for cos and sine graphs, because they repeat every 360 degrees. That's the period of the graph of what? Of a sine and a cos. For a tan, we add k times what? Times 180 degrees, because the graph of a tan repeats after 180 degrees. That's its period is 180 degrees. So this is what you're going to have. If you add or subtract any number of full revolutions to the solution, you get the same number. That is, if sine of A, we talked about this, then the general solutions can be taken from that. If you understand the way that they wrote, that's fine. For a tan, we talked about this, all right? If an equation contains double angles, e.g., sine 3 theta, cos 2x, tan 5y, first find the general solution for that given angle. Then divide by what? The coefficient. Here there's a 3, there's a 2, there's a 5. So you're going to divide by those numbers to find the final solution. So what are they trying to say? Let's say you have got something like this. 3 theta is equal to, maybe you got your answer as 100 and let's say the general solution for the angle that you have. Then you say, all right, in the second quadrant or in which quadrant, then you get something like 120. All right, you see now this pen is jealous. Anyways, let's say 120 plus K 360 degrees. Let's say this is what we had. You can divide by 3, by 3, by 3, each and every part up to 360 degrees. So that it will be theta is equal to this into this. That will be what? 40 degrees plus K times 3 into this. That will be what? 120 degrees. So this will be our final answer. We can divide by that. We are given a general solution, whatever that you are given, it is 2x, which is equal to minus, maybe the angle there is a negative, minus 30 degrees minus k times 360 degrees. It's a negative. You have got something like that. Divide by that 2 that you are given throughout so that you can have your x as negative 15 minus k times 180 degrees. It can be written in that manner in simplest form. This part of k times, it can have a negative here. Don't avoid it. When there's a negative, leave that negative as it is. Don't avoid it. Leave it as it is. All right. So this is how we can deal with such questions. So do revise as many questions where you do not understand. Let us communicate on the community section. All right. Apply restrictions where it is possible. All right. So these are some of the things that you must also consider as part of the general solutions, basic concept, understand everything, the simplification of trig equations, this and that, every part that you've done before, the trig ratios, identities, Cartesian plane, core functions, your factorization, everything that you've done, guys, you must know all those basics. Factoring of trigonometric expressions where it is necessary from the difference of two squares, any quadratic trinomial factorization, the use of the quadratic formula x is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. Remember all those, we are going to need it. And some identities, because maybe you're given an identity which is, or an equation which is mixed. There is sine of x, there is also a cos of x in one equation. So we have to change either a sine to be written as a cos or to change a cos to be written as a sine. So we must remember all identities that we have done before, such as the Pythagorean identities, the sine squared plus cos squared of theta being equal to 1, the sine squared of theta being equal to 1 minus cos squared, and cos squared being equal to 1 minus sine squared. Tan sine of theta over cos, and its reciprocal, 1 over tan, is equal to cos over what? Over sine. Remember that as an individual. The use of the trigonometric ratios in the Cartesian plane, the use of our quadrants. Remember, I talked about this. You must remember that. Your core functions also, please do remember these core functions. Remember the class that we discussed, these core functions. Please, guys, remember that. A trigonometric equation is true only for a certain values of theta. Write the equation on its own one side of the equation. Start by simplifying an equation as far as possible. Use identities where possible. Double angle, compound angle formula, factorization, even the Pythagorean identities, those square identities. Use them where it is possible. because you need one trig ratio and one angle equal to a constant. For an example, cos x is equal to, you just need one, not to say it is cos squared or no. We need it as one. Cos of x is equal to, if there are two, let it be a half and another one. The cos of x is equal to minus half, a single trig. One trig ratio and an angle and a constant. Is it the tan of x being equal to -2 being equal to 2? This is what we must have. Once we have that, determine or find the reference angle, where we talked about this. Reference angle is simply the arc sine, the arc cos. It is the arc tan of what? Of A, the modulus of A, take it as a positive. Then identify the positions, which is the possible positions of our quadrants. Identify the possible quadrants in which the terminal rays of the angle could be based on the sign of the function. That's where the sign now plays a role. There, we never used it. We just used the number that is there. Then you consider to sign the sign to say, is it positive or what? Negative, because that helps when it comes to the quadrants from the cast concept. The sign, which quadrant are we going to use? Consider restrictions or intervals for specific solutions. When you are given an exact solution from, you are now given your x must be taken from -360 degrees to 360 degrees. You are now to determine the exact solution to say x is 30 degrees, x is -150. You must take your answers in within the interval. Those are the restrictions in within what you're given. Not to say from -360 to 360, then your answer is 540. You say x is equal. No. It cannot happen. X is equal to 720. No. That cannot happen. Unless the interval has or contains that 540 degrees or 720 degrees. So you must be very careful when attempting your questions. This is what you need. The information that you need when attempting the trigonometric equations using the general solutions and determining exact solutions from those general solutions. We are going to obtain exact from here, guys. We're going to obtain exact solutions. Exact solutions can be obtained. For an example, let's say we've got something like x is equal to 30 degrees plus k times 360 degrees. Guys, k is an integer. So we try values of k from 0, negative values, -1, -2, -3, +1, +2, and so on. So let's say, for an example, if our k is equal to 0, therefore x is equal to what? So that's 30 plus our k, all right? I'm just going to put that one in a bracket, 0 there, times 360 degrees. That is going to give us what? 30 degrees. If, let's say, our k was equal to -1, in place of that k, we're going to put -1, like this, -1. And that was going to give us -330 degrees. It's a solution. If our k is equal to 1, we do the same thing. In place of k, there we put a 1. We have 390 degrees. If our k is equal to 2, we do the same thing. We are substituting. It gives us all the possible solution, every solution will be within there. But you must consider restrictions to say they are saying from where to where. If they're referring from x negative 360 to 360 degrees, less than this 360 degrees, it means our solutions were going to be minus 330, 30 degrees. We cannot take this one. We cannot take this one. It's out of the interval from this solution. Remember, there will be another one. You go to the second general solution, you do the same thing, you take in within that. Remember, for each given trig, it is going to give you two possible answers. Each has got two possible answers. When being a positive, there are two possible answers. When being a negative, there are two possible answers in terms of the general solutions. So from those general solutions, you work them separately. This one, you put the values of k, determine your solutions. You go to this one, you do the same. So it's all about revision now. Do revise as many questions as you can. All right. So without wasting your time, I just want you guys to consider just a simple example that we are going to determine the general solution. So in this case, I want us to determine the general solution. GS for general solution. Let me just write in for the general solution. All right. For cos of theta is equal to minus 0.766, all right? So if the cos of theta is equal to this, what will be our general solution? I don't want to work like deep into that one, but I want us as individuals go through, do as many questions. Guys, there are so many questions. There are some which are quadratic where factorization is to be used. There are some which are quadratic where the quadratic formula is to be used. There are some where identities are to be used. But at the end, you have a single trig, an angle, and a constant. This is how it is. Whether it started with a cos squared is equal to this, a sine squared. At the end, we must see properly cos or a sine or a tan of the certain angle, not a squared. All right. So in our case, it is properly given. We just need to consider the reference angle. So as part of our solution, what is our reference angle? Remember I said the reference angle, you determine the arc cos of the given decimal, which is its magnitude. Do not consider the sign that you're given there. All right. So our reference angle is going to be arc cos of what? 0.766. Do not consider the sign. The sign, it is for the quadrants. We are going to talk about that later on. So what is our reference angle? In our case, we are going to have, all right, this is our calculator. Arc cos shift cos 0.766. All right, so that was going to give us 40,00 and so on. So if we fix this one to two decimal places, 40,00, guys. All right, so that was going to be 40,00, which is just simply 40 degrees. Okay, that's our reference angle, that one. Where is it that our cos, because the cos that we have is what is negative? In which quadrant are we going to have it as a negative? In which quadrant? Cos. Second, third. We need solutions there. For a cos being a negative, this is what we are going to have. If A is negative for a cos, if cos of x is equal to A, and A is what? A negative. So your general solutions are going to be given as this. The angle in the second quadrant, 180 minus the reference angle, remember? And this one, 180 plus the reference angle. So therefore, as part of our general solution, x is the angle. In our case, it's not cos x, it's cos theta. Our angle is theta. So theta, the angle here, just like x. So if that was given as 2 theta, 3 theta, you write as it is 3 theta, 2 theta, 5 theta, as it is there. So there it is what? Theta. So theta is equal to what? The first solution in the second quadrant, it is supposed to be 180 degrees minus the reference angle. This is what we're supposed to have times k 360 of the period of the graph of what? Cos. So what is our reference angle? Remember, our reference angle is 40 degrees. So it's 180 degrees minus 40 degrees plus k times what? 360 degrees, being an integer. So this is our first solution. Let's simplify this and work out the second one. So 180 minus 40 is going to give us what? 140 plus k times 360 degrees. So this is it for all integers. This is the first solution where cos is negative in the second quadrant. But remember also there is another one that we have in the third quadrant, 180 plus the reference angle this time. So another solution was going to be given as what? X, which is our theta in our case. It's what? Theta. So theta is equal to what? The third quadrant, 180 plus reference angle. So you're going to add 180 degrees plus the reference angle in our case. So what is that reference angle? Remember, your reference angle is what? 40 degrees. So it's 180 plus 40 degrees. K times what? 360. So this is it. We can simplify that. So meaning to say theta is equal to what? 180 plus 40. That was going to give us 220 plus k times 360 degrees. And that's being what? An integer. So these are the general solutions that we are going to expect for this solution, where cos is what? Where cos is a negative value. A solution for the second quadrant, a solution for the third quadrant. Two possible solutions. So if it was a positive here, your answers were going to be taken from what? First and what? The fourth quadrant. Meaning to say you were going to use the concept here when it is in the what? First and what? Fourth quadrant, when it is positive, when A is positive. This is how we're going to represent our general solutions. Just like that. So it's nothing. General solutions, guys, it's nothing. It's nothing. It's all about more questions. So let's do revise, go through questions where there is a tan, mixed questions where there's a tan, a cos, a sine. Do them. Where we do not understand, let us communicate. And also do not forget to join the membership. If you are not yet part of the membership, join the membership so that you do not miss any of the other classes that you're going to have. And also for an opportunity for you to ask the questions that you actually feel like you do not understand, or maybe you're working on a specific question, then you are stuck. That is the advantages of the membership. So make sure that you join membership so that when you are stuck working these questions alone, you can quickly ask that question and we work it together on the same platform so that it can help you guys to prepare for the exams which are ahead of time. So that is it till we meet again.